This time I am not going to tell you the aim of the experiment. First let me do the experiment and then I'll tell the physics. See, what do I have with me? I have this aluminium tube. You see, there's a hollow rod, you can say. Its walls are very thick, and then there is a complete cylindrical hole from one end to another end. Then I have several other things. This is a copper tube, and this is a nut. This is a screw, and this is a candle. So you see, I have collected so many things, candles and tube, various kinds of things, and one special thing in my hand. I'll tell it about it later. So what I am doing now, I am putting this copper tube in this aluminium tube. I hold this aluminium tube in vertical position and put the copper tube in it and leave it. It falls. So let's put some other object. So this time I'll put this candle. So I take this candle and put it here and leave it, and it has fallen. And see how much time it has taken? Almost the same time as earlier. So nut, put the nut here, same story. Put the screw here, same story. And now this is special that I have in hand. I am putting that, and see what happens. I keep it here and I leave it now, and now it comes out. It has taken a really long time. Let's do it again. I am putting it here at the top and leaving it. I have left it. It is going inside the tube, and now it comes out. You see, it has taken much longer time than taken by the other objects, the tube and the candle and the plug top pin and all those things. So what is this special thing which is taking so long time? This special thing is a strong magnet. It's a very strong magnet. It's called rare earth magnet. When I leave it inside this tube, it falls through, and the magnetic field that it produces varies. At a particular place of this tube, consider here, at a particular place of this tube, consider this particular portion of the tube, the magnetic field here, as the magnet comes closer to it during its fall, the field changes. And similarly, at any portion you consider, the magnetic field changes when the magnet moves. This changing magnetic field produces induced EMF that you have studied, Faraday's law. Changing magnetic field produces induced EMF, and that drives current in this aluminium tube. And this current is such that current itself produces magnetic field, and that magnetic field applies a force on the falling magnet, and this force is to oppose the falling. The EMF is produced because the magnet was falling, so the induced currents will be such that they will oppose the falling. So the force exerted by this induced current and magnetic fields produced by them on this falling magnet will be to oppose the falling, that means in the upward direction. That slows down the motion, hence it takes much longer time. When you allow any other thing to fall, there is no magnetic field, no induced current, and it falls under gravity, and so it is very fast.